So this is MA IR11 course. The first unit in this course is matrices. So before I begin the contents, let me ask you something. You are familiar with the system of linear equations. Let me write a system. Say x1 minus x2 equal to 1 and x1 plus x2 equal to 3. If I ask you solve it, you will immediately solve. But I want to solve it using this format, Ax equal to b, the matrix format. You are familiar with it. So let's first write it in the matrix format. So how to write it in the matrix format? 1 minus 1, 1, 1, x1, x2, and 1, 3. This is the matrix format of this system of two linear equations in x1 and x2, right? Now, if you want to use the elimination method, what do you need to do? Make 0 here. So what operation you should apply? R2 replaced by R2 minus R1 means from the second row subtract the first row. What do you get? First row as it is, second row 1 minus 1, 0, and R2 minus R1 means 1 minus minus 1 means plus 2. Same thing you have to do here. 3 minus 1 means 2. Are you okay with this? You can write your answer in the chat box. Okay, I believe you are familiar with the three operations. We can interchange any two rows, elementary row operations I'm talking, that you have done in 12th standard. Ith row can be interchanged with jth row. Any row can be multiplied by a non-zero number. K is non-zero. And third is, any row can be replaced by that row plus constant multiple of any other row. Remember these three elementary operations. I think you have already done in your 12th class. So I've used the third operation here, means this Ri thing. R2 is replaced by R2 minus R1, but actually what I have done, I have eliminated x1 from the second equation. If you subtract from the second equation the first equation, what is happened? X1 is gone. And you are left with which system? If I want to write back this system, what is the reduced system? X1 first equation as it is because no change. Second equation 2 times x2 equal to 2. Correct? From this, x2 is easily available now. X2 is 1. And if you use x2 equal to 1 in the first equation, what do you get? 2. So what is the solution finally? x1 equal to 2 and x2 equal to 1. Is it correct? All right. Now, this Ax equal to B. If B is a non-zero matrix, then we call it non-homogeneous system of linear equations. If B is 0, what do you call it? This is homogeneous system of linear equations. So now I want to take up one example of homogeneous system. What if in place of 1 and 3, I'm writing the same system, but right hand side 0. You will write the same matrix form. The right hand side column is 0, 0. What system is left after applying the same operation R2 replaced by R2 minus R1? You are left with two equations, x1 minus x2 equal to 0 and 2x2 equal to 0. What solution you get? x1 0 and x2 0. Am I right? This is called trivial solution. Because when ax is 0, x equal to 0 always satisfies the system. This is called trivial solution. Now I'm writing one more example for you to think. X1 plus x2 equal to 0 and 2x1 plus 2x2 equal to 0. Can we solve the system by writing in matrix form? What is the matrix form of this? 1, 1, 2, 2, x1, x2, and right hand side it is homogeneous, so right hand side is 0, 0. Is it right? x1 plus x, I am writing a new system now. x1 plus x2 equal to 0 is the first equation. That's right, both equations are same. Solving these, okay? Let's see the solution. So what operation I should apply to make 0 here? R2 replaced by R2 minus 2R1 means multiply first row by 2 and then subtract from the second. What do you get? 1, 1, 0, 0. Interesting. This time you are left with only one equation. What is that equation? x1 plus x2 equal to 0. So what is solution in this case? What is solution? Because there are two variables, only one equation. So assume x2 equal to some constant, say a. So what is x1? Minus a. So what is your solution vector? x1 is minus a and x2 is a. So you can say that all constant multiples of minus 1 and 1 are solutions. In fact, a is any real number, so it has infinitely many solutions. So what I'm trying to tell you, ax equal to 0 is homogeneous system. If determinant A is 0, how many solutions? There are two cases, determinant A 0 or determinant A non-zero. Non-zero case you can see here in the first example, 1 minus 1, 1 comma 1. Here if you find the determinant of A, it is 2, that is non-zero. So you got only one solution, that is trivial solution. And if determinant A is 0, for example in this case, 1, 1, 2, 2, determinant is 0. So in this case, how many solutions? Infinite. I'm just revising something for you. You are already familiar with this, okay? This revision would be helpful. What I'm going to discuss next. Up to this, it is fine. You understand? A homogeneous system either has Trivial solution, that is 0. Trivial solution you get when determinant A is non-zero. And if determinant A is 0, it always has infinitely many solutions. All right. Now let's move further. The first topic of your course, Eigenvalues and Eigenvectors. Important. Eigenvalue is a complete word. There is no gap between eigen and value. Okay. Likewise, eigenvector is a complete word. Before I tell you the mathematical definition of eigenvalue and eigenvector, I want to tell you that these eigenvalues and eigenvectors have enormous applications in different fields. These have enormous applications. In the lecture notes, on the last page, you can see where these things find applications. Of course, we will not discuss applications. Our job is to learn the mathematical machinery that tells you how to find eigenvalues and eigenvectors. But after reading those applications, you can feel very motivated that why one should learn eigenvalues and eigenvectors. Okay. So definition of eigenvalue for a square matrix, say of order n cross n. Suppose A is a square matrix of order n cross n. Then a number lambda is eigenvalue of A if there exists a non-zero vector x that satisfies this equation. Lambda is a number, x is a non-zero vector. Remember that we are calling column vector as, this column matrix as I wrote earlier, x1, x2. This is a column matrix. We call it vector. Column, sometimes we call it column vector. If we write it in row form, we call it row vector. Anyway, I will call x as vector. Okay. So here x non-zero means x, I have taken n cross n matrix. So x is a column vector or simply vector carrying n entries, x1 to xn. So what is eigenvalue of a matrix A? If A is n cross n matrix, lambda is a number satisfying this equation, then it is called eigenvalue of A. And the non-zero vector x is called eigenvector. All these things are very clearly written in the lecture notes. Okay. Even if you are not noting down, no problem. You will see it properly. Here, just focus on understanding. So this is clear. Lambda is eigenvalue of A if Ax equal to lambda x for some non-zero x. Is this non-zero is important because x equal to 0 always satisfies it. We are not interested in that. In the exam, never say x equal to 0 is eigenvector, which is by definition not an eigenvector. Eigenvectors are always non-zero. Remember this, note this point very carefully because many of you in the exam will write. In fact, some problem will be given to you and you will solve this. Keep on solving, solution. You suppose you don't know what is solution, you will find it easily. X equal to 0 satisfies and you will write the answer that x equal to 0 is eigenvector. It means you have not seen the concepts clearly. Okay. If I am the examiner, I will do negative marking for this. Is that clear? I'm joking. So be careful. X equal to 0 can never be eigenvector by definition. So this condition must be satisfied for non-zero x. All right. Now, how to get the eigenvalues? See, I can write this condition in this format: A minus lambda in times x equal to 0. Do you agree with this? In is a unit matrix of order n cross n. I can write this thing ax minus lambda x. X is a column matrix, so I can write in here, no problem. X I have taken outside, so it's fine, right? Now see, this is homogeneous system, and this is the matrix of this homogeneous system, A minus lambda in. I am interested in non-trivial solution, x non-zero. So what should happen? Determinant of A minus lambda in should be zero, isn't it? I've told you already. For non-trivial solution, determinant of the matrix should be zero. Do you agree with this? I've told you just now here. If determinant is non-zero, you always get x equal to zero. But I'm interested in non-trivial solution. Non-trivial solution means determinant A must be zero. In place of A, here you have A minus lambda in determinant. So it's fine. This is called characteristic equation because this is the equation that will provide you eigenvalues of the matrix. This is called characteristic equation. All right. Now, this characteristic equation will provide you eigenvalues, and once eigenvalues are available for each eigenvalue, solve this thing. Lambda in times x, solve this homogeneous system to find your non-zero x. Those will give you the eigenvectors. Let's do a problem. You will find it easy. I'm writing a matrix. Take out your notebook. You will also solve with me. Let's take a 2 cross 2 matrix. 12 minus 51, 2 minus 11. Write this matrix. We need to find its eigenvalues and eigenvectors. So eigenvalues are given by the characteristic equation. It is 2 cross 2 matrix. So you will write A minus lambda I2 means 2 cross 2 unit matrix. This is the characteristic equation in this case. Let's simplify this further for the given matrix. A minus lambda I2 means what? Diagonal elements in A are subtracted by lambda. Am I right? Do I need to tell you the details? How I am getting it, or you understood? Okay, let me tell you the details. What is A matrix you are saying? What is I2? 1, 0, 0, 1. This is multiplied by lambda, so multiply by lambda. Now subtract. If you subtract the 2, then diagonal places are subtracted by lambda. So it's fine, right? Okay. Solve it. You should get a quadratic equation in lambda. You know how to solve determinant. And tell me the values of lambda. If you simplify it, you should get lambda square minus lambda minus 30 equal to 0. Further, lambda equal to 6 comma minus 5. Is it okay? Yes. You are agreeing with this answer. That's good. Now consider lambda equal to 6. You have found the eigenvalues of A because solving the characteristic equation means finding the eigenvalues. So eigenvalues are 6 and minus 5. Now consider lambda equal to 6. For this, solve this equation. This is matrix equation. Remember that. Means in this case, what is this equation? A minus lambda I2. What is lambda? In this case, 6. So let me put here 6 times x equal to 0. What is A minus 6 I2? Every element, the diagonal elements of A are subtracted by 6. Okay, subtract. What do you get? You get 12 minus 6 means 6 minus 51. 2 minus 11 minus 6 means minus 17. X, because it is 2 cross 2, so take a vector with 2 entries, x1 and x2. So you are ready with a homogeneous system. Remember that characteristic equation, when you are writing, it is determinant. You are taking determinant. It's normal equation, but here there is no determinant sign. It is completely matrix equation. Okay. Now, this is homogeneous system. You know how to solve it. Make zero here. That is the best policy, best way to do it. So what operation I should apply to make zero here? Write that operation. R2 replaced by R2 minus 1 by 3, 1 by 3 R1. Am I right? R2 replaced by R2 minus 1 by 3 R1. So what do you get after applying this operation? You get 6 minus 51 as it is, 0, 0. So as expected, you will get infinitely many solutions. That's why one row is coming out 0. If you are getting something non-zero here, it means something is wrong in your calculations. When you are finding eigenvector, at least one row should be 0. All right. So what is the reduced equation? Let me write here. What is the reduced equation? Only one equation you are left, 6x1 minus 51x2 equal to 0. One equation, two variables. Assume one variable as a. Say x2 equal to a. Doesn't matter. You assume x1 as a or x2 as a. So what is x1 then? 51 by 6a means 17 by 2a. Correct? Finally, how to write your eigenvector? Your eigenvector is x1, x2. And x1 you have found 17 by 2 times a. x2 is a times 17 by 2, 1. So there are infinitely many eigenvectors. All are multiples of 17 by 2 comma 1. Somewhere its answer can also be written by 17 2, because this a is any non-zero number. You can choose anything, okay? But anyway, you should write your answer in this format finally. You can leave here, no problem. So we will say that eigenvectors of A corresponding to lambda equal to 6 are non-zero multiples of 17 by 2 and 1. This is eigenvector. Any non-zero multiple of 17 by 2 comma 1 is also an eigenvector. Is it clear up to here? Any doubt you can write in the chat box. Yeah, it's not compulsory to make it 0, but I will suggest you to follow this approach. Okay, this is very good approach, because when you will go to 3 cross 3, you will see that making zeros is very useful. Okay, good. So can you find eigenvector corresponding to lambda equal to minus 5 yourself and tell me the answer? That is a good exercise for you. For lambda equal to minus 5, what is the equation that we will solve? A minus lambda I2, lambda is 5, so 5 I2 x equal to 0. Here this 0 is not normal 0, it is column matrix with 0 entries. Okay, solve it. I will not solve it. You will do it yourself. I would solve a 3 cross 3 now. Tell me your answer. In the lecture notes, it is already solved. Just confirm me the answer. It's the similar steps. Okay. After this, write a plus 5i2 and then apply some operation to make 0 in the second row. Finally, see what is your eigenvector. In this case, you should get a times 3, 1. Eigenvector is any non-zero multiple of 3, 1. You should say like this. Don't write like this 3, 1 or something. Eigenvector is this complete column matrix. Are you done with this? Yes, you should always express eigenvector as a column vector. Is this answer correct? A times 3, 1? All right. Now I want to explain a 3 cross 3 example. After that, you will do other problems yourself. So let us take a 3 cross 3 example. Rather, you should try with me. The matrix is -4, 8, -12, 6, -6, 12, 6, -8, 14. Write this matrix. We need to find its eigenvalues and eigenvectors. This time, the characteristic equation is A minus lambda I3. Means from the diagonal places, subtract lambda. -4 minus lambda, 8 minus 12 as it is, 6 minus lambda, 12, 6 minus 8, 14 minus lambda. You have to solve this determinant. There is no other option. See what do you get. This time you will get cubic equation in lambda. See what is that equation. I'm writing it here. You need to verify it. It is lambda power 3 minus 4 lambda square plus 4 lambda equal to 0. It is clear that lambda is common. Lambda square minus 4 lambda plus 4. Further also you can write it like this. It is whole square of lambda minus 2. So because cubic equation, you are getting 3 roots. 0, 2, 2. 2 is repeating. Got it? Okay, some of you have already got it. 0, 2, 2. Very good. Now consider lambda equal to 0 and find the corresponding eigenvector. So which equation you need to solve, which matrix equation for lambda equal to 0? A minus lambda is 0 times I3 x equal to 0. This matrix equation, the solution of this homogeneous system will give you the eigenvectors. Okay, this time matrix A as it is, write it. So it is -4, 8, -12, 6, -6, 12, 3, no, it's 6, -8, 14. After this, it is important to see how we get the infinite solutions from it. It is always good to make 1 at the first entry. It is always good. So what operation I should apply on the first row so that I get 1 here? Replace R1 by minus 1 by 4 R1. Am I right? If I multiply first row by minus 1 by 4, I will get 1 here. So minus 1 by 4 means it is minus 2 and this is 3. No need to think other side because there are zeros only. So write 0, 0, 0. Others as it is. Now use this 1, the first entry, to make zeros in the first column. I have made this 1 to make zeros in the first column. So what operations I should apply? R2, replace R2 by R2 minus 6 times R1, and R3 also 6 times R1. That will give me zeros at these places. Am I right? Apply these operations yourself. See what do you get. 1 minus 2, 3. First row, we are not doing anything. Second row, elements are subtracted by 6 times R1. So it is 0. 12 minus 6, 6. Minus 18 plus 12 minus 6. Again 6 minus 6, 0. Minus 8 plus 12. How much? 4. And 14 minus 18 minus 4. See whether I have written all things correctly. Tell me if means. I will not suggest you to solve these equations directly. Apply operations. This is the most easier way to do. Okay, we'll discuss these things after the end of the lecture. It is correct as you're saying. Whatever whatever calculations I've done so far is correct. Now make 1 here, because making 1 here is not creating any fraction. So which operation? R2 is replaced by 1 by 6 R2. Right again. 1 minus 2, 3, 0, 1, 1, 4. No, 0, 4 minus 4. All right. Now, because 1 I have made here, I have made 1 here. Use this 1 to make 0 in the second column. Let's do it. So which operation? R3 is replaced by R3 minus 4 times R2. 4 times R2. Apply this and see what do you get. 1 minus 2, 3 as it is. 0, 1, 1 as it is. 0. And then what do you get here? No, here what I have done, minus I have missed. Okay, because I've divided by 6. So you get 0 here also. Is it correct? Yes, minus 1 again. Yes. Is it correct now? It is correct. So which equations you are left? Write the equations back. The first equation now is x1 minus 2x2 plus 3x3 equal to 0. Second equation is x2 minus x3 equal to 0. There is no third equation. Two equations, three variables. So naturally assume one variable, some arbitrary constant, say a. So second equation gives you x2 equal to a. And the first equation, what do you get from first equation? If x2 is a, x3 is also a, you get minus a. Yes. So what is your eigenvector in this case? x1, x2, x3, and x1 is, no, this is x1. x3 is a, x2 is a, and x1 is minus a. So you get minus a, a. A is constant, take it outside. So minus 1, 1, 1. Is it okay? So any non-zero multiple of minus 1, comma 1, comma 1 vector is eigenvector. Non-zero multiples, of course. X equal to 0 is never eigenvector. If you write it in the exam, you will get less than 0 marks. Okay, so be careful. Eigenvector is never 0. So you leave it here and say that this is the answer for eigenvectors where A is non-zero. A is any non-zero real number. Okay, similarly, I have solved one 3 cross 3 case for you. Same way, can you find eigenvector for lambda equal to 2? This is good exercise. If you do it, it's wonderful yourself. I will not do it. I want you to do it now. For lambda equal to 2, what do you get for x1, x2, x3? Lambda equal to 2 means a minus 2i3 x equal to 0. This equation you will solve, this homogeneous system. Can you try it right now or you will do it later? Can do it right now, it would be nice. Okay, I'm writing the final step. Intermediate steps you will see yourself. When you will write it in matrix form and apply suitable operations, you will reach to this step. 1, comma 1 minus 4 by 3, 2, 0, 0, 0, 0, 0, 0. Interesting. This time you'll get two rows completely 0. Means you are left with only one equation. Only one equation. Which equation? x1 minus 4 by 3x2 plus 2x3 equal to 0. So in this case, how to write eigenvector? No problem. There are two unknowns, two more unknowns, only one equation. Three unknowns, one equation. It means two variables you have to assume from your side. Say x2 equal to a and x3 equal to b. Okay, so what is x1 then? 4 by 3a plus 2, no, minus 2 times b. So what is your eigenvector finally? x1 is 4 by 3a minus 2b, x2 is a, x3 is b. Let's separate these constants. We will say something interesting. 4 by 3a, I can write this column matrix in two column matrices. 4 by 3a, a0 plus minus 2b, 0b. Is it clear? If I add these two column matrices, I get the previous column matrix. Correct or not? Okay. By this way, it is a times 4 by 3, 1, comma 0 plus b times -2, 0, -2, 0, and 1. So for lambda equal to 2, what is the situation? Any combination of these two vectors, at least either A should be non-zero or B should be non-zero. Any combination of these vectors is an eigenvector. Any linear combination of these vectors is an eigenvector. All right. In fact, there are two independent eigenvectors, 4 by 3, 1, 0, and other is -2, 0, 1. These are independent. What is the meaning of independent? Linearly independent eigenvectors means they are not multiple of each other. For example, if one eigenvector is 1, 2, and other is 2, 4, these are not independent. These are dependent because they are multiple of each other. If I multiply first one by 2, I get the second one. But here, this is not the case. So these are independent eigenvectors. Okay. So any linear combination, this also gives an eigenvector of the matrix. If I assume B equal to 0, what do I get? A times this, all these are eigenvectors. If I assume A equal to 0, B times all these are eigenvectors. If I keep both A and B non-zero, still it will be an eigenvector. Okay. So in this case, this is the way to write the eigenvectors. Details are written in the lecture notes, you can see there. So is this example clear to all of you? Okay, very good. Now you can do eigenvalue, eigenvector problems. But before that, let me ask you a quick example. Suppose I write this matrix. Can you quickly tell me the eigenvalues? You know, this is upper triangular matrix. What are its eigenvalues? Without solving anything, can you think? 113. Why are you saying this? Because if you find A minus lambda I3 for this determinant equal to 0, what do you get? You get lambda 1 minus lambda 2, 3, 0, 1 minus lambda 2, 0, 0, 3 minus lambda. Determinant of this matrix is simply the product of its diagonal entries. You know this property of upper triangular matrix. So if it is upper triangular or lower triangular or a diagonal matrix, the eigenvalues are nothing but the diagonal entries. Okay, make a note of this. So if I ask you what are eigenvalues of a unit matrix of order 3 cross 3, what are eigenvalues of a unit matrix of order 3 cross 3? What is your answer? 1, 1, 1. Very good. And what are eigenvalues of this matrix? 0, 1, 0, 0, 0, 1, 0, 0, 0. What are eigenvalues of this? All 0, because diagonal entries are 0. Okay, and it is upper triangular matrix. All right. So in this lecture, we have done some very important things. I have explained you what is eigenvalue, what is eigenvector. Then for a 2 cross 2 matrix, we found eigenvalues and eigenvectors. And then for a 3 cross 3 matrix. After this, what you can do, you can practice some problems based on eigenvalues and eigenvectors, especially 3 cross 3 matrices. Practice some problems from your side. Then you will be confident how to do. And most importantly, you should see the definitions, the concepts very carefully. Don't close your eyes. If I have said x non-zero by definition is eigenvector. If x is zero, it is not eigenvector. Students do this common mistake. They are finding eigenvector. For example, this. Solve this equation, write everything. In the end, somehow they are not able to solve the homogeneous system. They find it easily. X equal to 0 is satisfying. It always satisfies. What are you telling? If I put x equal to 0, it is always satisfied. So you have not solved anything. And x equal to 0 by definition is not an eigenvector. So how can you write it in the answer? So be careful, okay? Listen the concepts very carefully and then practice some problems. Then you'll be confident while writing what you are writing. Okay, so practice some problems on it and we will meet in the next lecture.